All right, section 8.2, the law of cosines. All right, so in the last section, we were solving oblique triangles using the law of sines. And the law of sines was good for angle, angle, side, angle, side, angle. And then that side, side angle that we didn't really do. So we just did those other two. Okay, so the other two cases that we had were side, 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 and side, angle, side. So those are going to be the ones that we can use the law of cosines for. All right, so what does the law of cosines say? Again, it's going to use the same notation with the ABC, alpha, beta, gamma being across from the appropriate side lengths. Okay, and the law of cosines looks like this. A squared equals B squared plus C squared minus 2BC cosine alpha. All right, and the law of cosines to me looks a whole lot like the Pythagorean theorem at the start, right, where we have this kind of relationship. The Pythagorean theorem, we always say A squared plus B squared equals C squared because the hypotenuse had to be by itself on one side. All right, there is no hypotenuse in an oblique triangle. Okay, so it doesn't really matter which sides we call A, B, and C. All right, so we just say these three side lengths are involved. Okay, and then B and C here get repeated in the formula there, times the cosine of alpha, and alpha being the angle that's opposite side length A. All right. So you can kind of think of this as the Pythagorean theorem with this little extra bit on the end to sort of compensate for the fact that we don't have a right triangle. All right. So your book will list this formula 3 times. It's going to tell you it's this, and it's this. And I think this is really overkill. It's sort of ridiculous because this is really the same formula written 3 times. Okay, so I would just kind of stick with the first one. Just notice the pattern. Okay, whatever the 2 side lengths are here, they get repeated at that spot in the formula. Same thing here, and same thing here. Okay, because it doesn't matter which sides we label as A, B, and C, it's really the same thing. And then whatever side length is by itself over on the left, its angle, its partner angle shows up in the cosine part of the formula. Okay, so this isn't really 3 different formulas. It's the same formula written 3 different times. And so really I would just kind of copy this down with one of the 3 notations and stick with that. All right, and again, the law of cosines is going to solve for us if we know all 3 side lengths or if we know side, angle, side. Okay, meaning 2 side lengths and the angle that's in between them, like these 2 side lengths and the angle in between them. All right. So all we're going to do is a couple of word problems and be done with it. All right, so they tell us to draw a triangle with A equals 8, B equals 12, and C equals 17. Find all 3 angle measures. Okay, so again, it's not really important that you pull out a ruler and get this right. It doesn't even tell us 8 what, inches or centimeters or whatever. Okay, so we're just going to have a short side, slightly longer side, and an even longer side than that. Okay, so I'm going to say this is 8, 12, and 17, and I appear to have almost drawn a right triangle. Again, doesn't matter just as long as I label everything with the right side length. So I'm going to name those sides. I'm going to call this A, this one B, and this one C. All right, and that means across from side A has to be angle alpha. That's that angle. Across from side length B, this one's got to be beta, and across from C has got to be gamma. All right, so I'm just going to copy down the law of cosines. Since we know all 3 side lengths, it doesn't matter which version we start with. Okay, so it starts off looking like the Pythagorean theorem. Then it's got this 2 in there. I need to copy down whatever 2 side lengths show up there. Okay, so 2BC times cosine, and I have to have the angle that's across from angle A, which is angle alpha. All right, So the only thing I don't know there is that angle alpha. That's going to be the thing that I'm solving for. Okay, so side length A is 8. I'm going to have 8 squared equals 12 squared plus 17 squared minus 2 times 12 times 17 times cosine alpha. Okay, so I'm going to be solving for cosine alpha. So all I'm going to do is kind of simplify all these numbers. It's important to know, like these numbers here, 2, 12, 17, those are stuck to the cosine, but these two numbers are not, so you can't combine them all at once. Okay, so 8 squared over on the left is 64. Then I'll do 12 squared plus 17 squared. That's 433. And then we'll have the coefficient here, 2 times 12 times 17. Gives me 408 cosine alpha. Okay, and just treat the cosine alpha like your variable. We're going to subtract 433 from both sides. Okay, so I'm going to say 64 minus 433. So I get negative 369 equals negative 408 cosine alpha. So now we're going to divide by negative 408. I get 0.9044. I'm going to keep all of these decimal places in my calculator. I'm only going to write down a couple of them. Okay, and now we need to solve that equation. Cosine alpha equals 0.9044. All right, and by now we've talked enough about how we don't divide by COS. We can't divide by the symbol of a function. All right, and we learned about solving trig equations. We learned about inverse trig functions, and that's how we're going to solve for this. We want to rewrite this. Remember, inverse functions swap input and output. Okay, so we'll end up with the cosine inverse of 0.9044 equals alpha. Okay, so the alpha was inside the cosine. That means it's outside the cosine inverse. 0.9044 was outside. That was the output of cosine. It's the input of the cosine inverse. All right, so I'm going to do my cosine inverse. I'm going to do cosine inverse of all of those decimal places in my calculator that I didn't write down on the sheet, just to make sure I get a good, accurate answer. And I get 25.2558261. Okay, and that, though, is my final answer. I'm going to round off. That's 25. Yeah, we'll just leave that as 25 degrees. Okay, so I'm going to label that up in my diagram. 25 degrees. All right. And now I want to solve for the other two angles, gamma and beta. All right. So now, let me get rid of all this stuff that we just did. All right. Now, technically, let's say I'm going to solve for beta. All right. So if I'm going to solve for beta, I actually could use the law of sines here. Okay. Because I have sine beta. I have beta that I'm looking for. I know the side length across from it. And now that I know angle alpha and the side length across from it, I could use the law of sines. Using the law of sines to solve for an angle, that's that case that we skipped in the last section, the ambiguous case. Solving for an angle with the law of sines is kind of treacherous, and it can cause a little bit of trouble. The law of cosines does not have this problem. So if you're solving for an angle and you can at all choose to use the law of cosines, I would definitely recommend that. So since we can use the law of cosines, I'm going to. So if I want to solve for angle beta, all right, that means that I need to make sure that side length B is by itself over on the left. Okay, so I'm going to say B squared so that I can put cosine beta at the end of the formula. So that means I have to have the other two squared here. Cosine, let's see, minus 2. Always need to use these two side lengths. AC cosine, and again, I'm using the angle that's across from that side length that's by itself. All right. And again, I just arbitrarily chose to solve for beta. I'm going to have to solve for gamma as well. Okay, but I'm going to solve for beta first. All right, so plug in everything that we know. We know side length B is 12 A is 8, C is 17. And cosine beta is what we're solving for, so I leave that. Again, we're going to simplify these two numbers and those numbers in our first step. So 12 squared is 144. Then I've got 8 squared plus 17 squared gives me 353. 2 times 8 times 17 gives me 272. All right, and do the same thing we did last time. It'll look exactly the same. We're just going to solve using some algebra skills. Subtract 353 from both sides. Yeah, negative 209. Right, divide by negative 272. I get 0.768 and change. All right, and again, I'm keeping all those decimal places in my calculator. I'm just not copying them down so that I can type that in. Again, we want to solve for beta using the cosine inverse function. Okay, 0.768 is going to be the input, and cosine inverse will tell us angle beta. So I'm going to do shift cosine of all of those decimal places in my calculator, and I get 39.79. I'm going to round that up to 40. Okay, and you can be as accurate as you need to be depending upon how important it is that you get the angle exactly right. Okay. Of course, your homework, the computer's going to tell you how many decimal places to keep. If I'm concerned about it on the test, I'll give you round to 2 decimal places or something like that. All right. And now, let's see. I was supposed to find all 3 angle measures. I found 2 of them. For my last one, gamma, I could use the law of cosines again, but that would kind of be using a sledgehammer to push an attack. Okay, because I've got 2 angles here. I can just do the old-fashioned subtract from 180. Okay, so 180 minus 40 is 140, 115. All right, and obviously I did not have a 115 degree angle drawn there, and that's fine. As long as we get everything labeled right. Okay, so those 3 angles are our solution to that one. All right, so that was solving a side, side, side using the law of cosines, where we solve for an angle using the inverse cosine. Our second example is going to be our side angle side. And this one we're going to have to draw a diagram for. Okay, so it says, suppose a boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles. How far from port is the boat? Okay, so we'll have our port here, and it doesn't really matter what direction. It doesn't kind of tell us what direction. It travels 10 miles. It turns 20 degrees. Okay, so I'm going to kind of extend its trajectory pass here and turn it 20 degrees. Oops, certainly isn't 20 degrees. How about that? One more try. That's better. Okay, so the boat has turned 20 degrees and it's traveled another 8 miles. Maybe a little shorter. Okay, how far? Hang on here. I'm going to move this 8 up onto the top of this line here. Okay, so how far is the boat from port? Okay, so that is going to be this distance here. That's the distance. So here's my boat. After it's traveled 10 miles and then another 8 miles, how far is it from port? Okay, and you can see this is a side angle side almost. All right, we know 2 sides of this triangle. And really, we do know the angle between them. That angle is going to be supplementary. It's going to add up to 180 degrees. with that 20-degree angle. Okay, so that one's going to be 180 minus 20. Okay, so that gives us a 160-degree angle. All right, so that's our side angle side. We know 10, 160 degrees, 8, and we know we can use the law of cosines here. So I'm going to copy down the law of cosines. And I haven't labeled anything with A and B and C, so I can copy down with any letters. We just have to follow the pattern. Whatever the two sides are on the right have to be repeated, and then whatever side is over here, its angle is over there. Okay, so let's see. Since I know angle 160, that's the only angle that I've got in my triangle, then the side across from it has to be over here on the left. That's got to be my X. Okay, so I'm locked into that because I can't find those other two skinny angles at the port or the boat. Okay, so that's going to be my X, which means that the other two are going to be my 10 and my 8. And it doesn't matter which one's B and which one's C. All right, so I'm going to have X squared equals 10 squared plus 8 squared minus 2. The B and the C get repeated, 10, 8, cosine. And this time I know the angle that I'm looking for. All right. And solving a side angle side with the law of cosines is really pretty easy. You can just type this stuff straight in to your calculator, the entire right-hand side of the equation exactly as it looks. 10 squared plus 8 squared, 100 plus 64, minus 2 times 10 times 8 times cosine of 160 gives me 314.35. And again, I'm going to keep all those decimal places in my calculator. All right. And then that is just a regular quadratic equation. X squared equals 314. Take the square root of both sides. Normally I do plus or minus when I take the square root of both sides, but this is a distance. We don't need a negative distance. So I'm just going to use my calculator to take the square root of all those decimal places that I kept, and I get 17.7. 17.729943132. Right, so 17.7, and then that was actually what I was looking for, that distance X between port and boat, and it just needs some units, and my units in the problem were miles, so that's 17.7 miles. And that's it. Okay, so side angle side is a little bit easier than side with the law of cosines because you don't have to use inverse trig functions to solve. All right, and that is it for section 8.2. All right.